Welcome everybody to our Algebra 2, Algebra 1 review, kind of our conclusion to Chapter 0 here to get the year underway. We've got a quiz coming up over our Algebra 1 concepts that we've been reviewing. Again, we just want to make sure that we understand everything as well as we can, and sometimes we just need a little checkup on our way through moving into Algebra 2 here. So that's what this review packet is designed to prepare us for. And it's not terribly long. There's not a lot of skills. Again, we've only spent 3 days kind of reviewing this stuff, most of it dealing with linear and absolute value functions. And, this is just an opportunity that as you've been reviewing that you can go back and just kind of check your process on some of these problems. So I hope you find this informative. If at any point you find that I'm moving kind of quickly through these, I am. That's just to try and keep this video pretty short. But feel free to pause at any time, or you can go back and revisit an example because it is me moving kind of quickly just to help you out as much as possible. All right, that being said, let's get started with our Algebra 1 review. So here we have solving equations. You can see there's quite a few things happening here on the page. A couple problems that have fractions to deal with. There's an absolute value problem as well. Problem number 1, to get that one started, I recognize that there's a little distribution that needs to take place there. So that's 56 plus 7m equals 91. And if I subtract away 56 from both sides, find that 7m equals, what would that be, 35? Divide both sides by 7, and m equals 5. So there we have that first problem done. I'm sorry, my smartboard is being a little glitchy on me. So if my handwriting is not perfectly clear, I'll try and correct that as quickly as possible. So that's one way of doing this problem that I think a lot of you are familiar with, the distributive property and combining like terms just to solve an equation. Problem number 2, if you look at that, it's a similar setup as problem number 1, where it looks like just a distribution problem, but there's a little bit more happening because of the fractions. They make this problem seem much more intimidating than it actually has to be. So here's what I'm going to do. It's a little bit different. Instead of distributing this 7/2 into the problem, that's just making my fractions a little bit more intense. It's totally possible. I'm not going to take that option away from you, but I'm going to suggest this instead. What if we divide away this negative 7/2? Then we wouldn't have to multiply it in using the distributive property at all, and we'd get rid of one of our fractions, hopefully. To divide away a fraction, I'm simply multiplying by its reciprocal, so I'm going to multiply both sides of that equation by -2/7. And I still have -7/2x plus 1/2. Oh boy. Let me just go back and clear that up. I've reoriented my board, so hopefully my handwriting will be a little bit clearer. I'll have -7/2x plus 1/2. And then on the right, I've got 35 times -2. That's -70 over 1 times 7, 7 in the denominator. That's just a -10. So that's made it quite a bit nicer to look at, right? We've gotten rid of one of the fractions that it was kind of plaguing us early on. Then I've got fractions that are divided by 2. Let's go ahead and take a second and multiply both sides of that equation by 2. -7x plus 1 equals -20. So in a couple of steps, we've gotten rid of all the fractions there, and that's going to make it a little bit easier to work with. Now, is this the only way to do the problem? Absolutely not. You could distribute and work with the fractions and get the correct answer every single time. I'm just kind of showing you what I think might be a little bit clearer. Let's finish solving. We'll subtract 1 from both sides, then -7x equals -21. Divide both sides by -7, and I get x equals 3. For problem number 3, more fractions happening here. Let's try that approach that we did up above, because, again, the faster I can get these fractions out of the way, the better I feel. So I'm going to divide away 5/2. That means multiplying both sides by the reciprocal, 2/5. Okay, that will cancel that out on the left. All right, now 415 times 2 divided by 5 times 12. That's quite a bit of simplifying, and you're going to be allowed a calculator. If something like this shows up on your quiz, I'd probably encourage you to use that just to be sure. But I know that 2 divided by 12 is the same as 1 over 6, and 415 divided by 5 is the same as 83 over 1. So 83 over 6 is equal to negative 11 thirds n plus 1. And again, the smartboard's acting up a little bit because of the humidity in the room. I do apologize for that. I'm going to take both sides of this equation because I still don't like the fact that I've got fractions over 6 and over 3. And I'm going to multiply both sides by a number that can be divided by 6 and can also be divided by 3 cleanly. I'm going to multiply both sides by 6. So on the left-hand side, the 6's cancel out, and I get 83. And on the right-hand side, I have negative 11 times 6 divided by 3. That's like negative 11 times 2. And then 1 times 6 is just 6. So again, we get to an easier problem to work with when we get those fractions out of the way. Oh, I'm skipping steps here. That was a 22. So I'm at the point where I have 77 equals negative 22n. That's what I meant to write. Then I'm going to divide out the negative 22 and simplify for my answer. N equals negative 7 over 2. And lastly, solving absolute values. This came into play in the third and final day of our review. First task, we need to isolate the absolute value. So let's add 4 to both sides. Really tempting to do negative 4 plus 7, but that 7's multiplied onto the absolute value. So we got to get rid of that loose negative 4 before we take care of the 7. Separate steps. To finish isolating the absolute value, I'm going to divide both sides by 7. All right, and then just a quick check. Is this an absolute value that has 2 solutions or no solutions? And taking a quick look, that absolute value is equal to a positive number, so that means I've got 2 solutions. I need to set up those 2 equations. What's inside could equal a positive 4, or what's inside could equal a negative 4. To solve either of these, we simply subtract the 8 from both sides and divide by 3. So x equals negative 4 thirds. There's one of my answers. Perform the same steps with that other equation. I get x equals negative 4 as well. So as you can see, we open up with some solving problems. Not a huge surprise. A lot of algebra is simply solving for x. One of the next topics that we covered was evaluating functions. Remember that evaluating or simplifying in certain cases just means substituting in, really. So we're learning how to read our function notation, or actually relearning how to read that and work with it. So number 5, my function's name is p. It takes x's as inputs. We are going to input a 5. That's what they're asking us to find. So p of 5 is going to happen when I have a negative, not x, but 5 as an input, plus 3 inside an absolute value, and then plus 2 afterwards. Okay, so what that equals is absolute value of negative 2. I have to simplify that first if possible. What is the absolute value of negative 2? Well, it's 2. So I'm really just doing 2 plus 2. My answer should be 4. For problem number 6, here we see some exponents. Our function's name is h. They want us to input a 4 into that. So h of 4 is going to be not x, but 4 to the third minus 2 times not x, but 4. And 4 to the third power, we may have to use a calculator for that, but it's 64, and that's a good one to just kind of have memorized. It comes up pretty frequently the rest of the year. 2 times 4 is 8, so my final answer should be 56 once I simplify that all the way down to a single number answer. For problem number 7, here we got a function p, and we are inputting an 8 into that function. Remember, that does not mean p times 8, it means p with 8 as an input. So p of 8 equals negative 3 times not a, but 8 squared, and then minus 4. Okay, that's negative 3 times 8 squared. I got to do the exponent first before I multiply. That's 64. Negative 3 times 64 is negative 192. And again, we may need a calculator for that. Final answer for p of 8 should be negative 196. Now, those 3 problems were the ones where the direction should say evaluate. For numbers 8, 9, and 10, it should technically say simplify. Because when they tell us to evaluate, that's when we get a single number for an answer. That's what we saw in 5, 6, and 7. But for these last 3, you can tell from our inputs that we are actually inputting an expression. There's still variables there. So we're going to simplify an expression at the end. We're not going to get a single number answer. But it works the same way. My input is 1/2 x. So g of 1/2 x is 2 times not x, but 1/2 x, and then plus 1. And then we just simplify that as much as we possibly can. 2 times 1/2 is 1 x, and then plus 1. And that's as simplified as I can make it. We're done with that problem. For number 9, here I'm finding g of negative 2x. That's 2 minus 4 over 3 times that input, negative 2x to the second power. And we're just going to use order of operations to simplify that thing. I can't do the multiplication yet, so that 4/3 has to stay out front. And I'm taking negative 2 times x, all of it to the second power. So I've got to square negative 2 and square x. And we're ready for our final answer, I believe. Once we multiply that 4/3 times 4, get 16/3 x squared with the 2 minus out front. Okay, and final problem from this section. Here we are substituting in negative 2 minus n into our function f. So f of negative 2 minus n is equal to 2 times that input plus 5 over 3. And to clean it up, I can just distribute, maybe combine some like terms just to, again, simplify, not necessarily evaluate. So we got negative 4 minus 2n plus 5 over 3. I need to combine this negative 4 with this 5/3. They're both just numbers. They are like terms. So we're going to have to get a common denominator to do that. Negative 4 is the same thing as negative 12 being divided by 3, and having that expressed as something over 3 is going to allow me to combine those together. So I still have that negative 2n, but now negative 12/3 plus 5/3 is negative 7/3. Since they have that common denominator, I can add up their numerators over that common denominator of 3. All right, and it should be known that numbers 9 and 10, if you had those terms just in a different order, like say for number 10 you had negative 7/3 minus 2n, that's still totally acceptable. It means the same exact thing. All right, from there we move on to our graphing section. And you can see we have a few linear equations that have x's and y's, and then number 14 is an absolute value graph that we have to produce. For 11, 12, and 13 are linear functions. It's going to be very helpful for us to write these as slope-intercept form. In slope-intercept form, it's just much faster to graph that way. So for number 11, the first thing I'm going to do is subtract the 30 and add 3x to both sides. And just to save space, I'm going to do that without writing all the steps. I hope that's okay with you. Then I got to divide everything by 15, and I end up with y equals 3 over 15 is 1/5 if I simplify it. 30 over 15 is 2. So 1/5 x minus 2. I'm going to plot that minus 2 on the y-axis. That's my y-intercept. And then use rise over run, that 1/5, to chart out a positive slope. And I'm just going to keep that pattern going. The more points that I can plot accurately on that grid, the more accurate of a line I can draw. It's not something that's absolutely necessary, but it does certainly help make a more accurate graph. All right, for number 12, here let's do the same thing. I'm going to subtract 4y from both sides and then divide everything by -4 to set that up as y equals mx plus b. Okay, and once I have that form, I plot that y-intercept of +4 on the y-axis. My slope is -7/4, so I'm going down 7 units for a rise and then 4 units to the right for a run. Those are the only 2 points that I can fit cleanly on that graph. So I connect those to make my line. All right. Number 13, wow, here we got some interesting things happening, right? I'm going to add the 1 and add the 3/8 x to both sides. So 1/4 y equals +3/8 x and then +1. And then to undo the 1/4, I'm going to multiply both sides by the reciprocal, 4. So y equals 3 times 4 is 12/8. 12/8 is 3/2. And then 1 times 4 is 4. So again, I'm sorry I'm not showing all those steps written out along the way. I'm just trying to save space so it's easy for you to read on your screen. If you have any questions or you can't get that to match up, please come and see me to ask about this. I'd be happy to clarify the steps. Again, once we have slope-intercept form, though, that mx plus b, man, is that easy to graph. I want to go up 3 and to the right 2. And if I try and do that up and to the right, I kind of run out of graph space. So I'm going to have to go down 3 and to the left 2 to keep that pattern going. And I can keep that pattern going quite a bit down and to the left. There's the graph of that line. For number 14, our absolute value function that we're graphing. Remember, we did this by making a table of values. And we want to find the most interesting value of x. What's going to be the x-coordinate of the vertex? In other words, what x value would zero out that absolute value? In this case, if x were equal to 2, then my absolute value would zero out. Now let's get the output, the y value that happens when I plug in x equals 2. I'd have -3 times 0 and then +4. So the point 2, 4 is my vertex. Let's fill in the rest of our table with a couple points on either side, just to plot some more points and see this graph fully. If I plug in a 1, -3 times, let's see, absolute value of 1 minus 2, that's -3 times 1 plus 4. So 1 there. And if I plug in a 3, the same thing will happen because that absolute value doesn't care if it's 1 or -1 inside, it will still output a 1. I'll get the same output when I plug in an x value of 3. There's wonderful symmetry here with our absolute value functions. And if I plug in a 0, I get -3 times 2. That's -6 plus 4, which is -2. And of course, the same thing would happen if I plugged in a +4, because it would make that absolute value also output a +2. So let's see, 4, -2, and 0, -2. And we see our points lining up beautifully to set up this absolute value, the V-shaped graph that those produce. 2 lines that have a vertex, or 2 linear portions that have a vertex. Right, after that we start writing equations of lines, and this is the final section of our review packet. And for this particular set of problems, you can see they're basically like how we started the last section. We already have an equation, it's just not in the form y equals mx plus b. So we're just going to have to do some algebra steps to make that happen. For number 15, I'm going to subtract 7x from both sides, and then divide everything by -5 to arrive at the answer. For number 16, here I'm going to subtract 2x from both sides. And then divide everything again by negative 5 to arrive at that final answer. For number 17, here this is going to be kind of interesting. I'm actually going to subtract 4x from both sides. Because when I do that, I've isolated the y term, and because these two things are equivalent, it doesn't matter if I write that as 5y equals negative 4x plus 25. It's like the reflexive property from geometry. All right, final step is just to divide everything by 5. So we can see that y equals mx plus b format. And lastly, number 18, kind of similar in nature, I'm going to add 4 to both sides. Then divide everything by 2. And then just rearrange that so it appears like y equals mx plus b. I'm going to put the y equals out front, negative 2x plus 2, just so it reads in a familiar fashion. All right, and from what I've seen in my classes, this type of algebra is something that students seem to remember very well from Algebra 1. So hopefully this is just a little bit of practice of something that we're already confident in. I certainly hope so. All right, and then our final set of questions here, writing the equation of the line in slope-intercept form if we're just given some random pieces of information about it. So numbers 19 and 20, here you can see we're given a point and a slope. So we have to go through point-slope form. We've got x1 and y1, and we've got an m. So here's what point-slope form would look like for number 19 with the numbers plugged in. Y minus 2 equals 4 over 7 times x minus 5. Then we got to distribute the 4 over 7. And then we need to add over the 2. And I'm just going to say that that 2 is the same thing as 14 divided by 7, just because they mean the same thing. They have the same value, but I've got my common denominator there. It just saves me a little bit of scratch work. And when I combine like terms, since they have their common denominator, I get negative 6 over 7 for that y-intercept. Number 20 has the same general setup, so let's see what point slope would look like to get this thing started. Y minus negative 1 equals 2/3 my slope times the quantity x minus 3. Let's distribute that 2/3. 2 divided by 3 times 3. Well, divided by 3 and times 3 cancel each other out. That's just negative 2. And then we'll subtract 1 from both sides to arrive at our final answer. Not too much of a chore. And then lastly, 21 and 22. Here we've got 2 points that are going to be our only pieces of information given. We don't have a slope. Our saying goes in our class, if we're slopeless, we're hopeless. So we got to find that slope first. And to find the slope, remember, if I got x1, y1, x2, y2, I take my second y value minus my first y value over my second x minus my first x. Here I get negative 10 over negative 4, which is positive 5 over 2 when I simplify it. And then here I don't have a y-intercept given. That's what happened in our example like this in the notes. But that's okay, right? I can still use point slope. I just need to decide which one's easier to work with. And I like the first one, actually. Even though the numbers are a little bit bigger, in that one, they're both 5s. So there's less of a chance that I'll make a mistake plugging the number into the wrong place. So y minus y1 equals slope of 5/2 times x minus x1. You could also use the other point. You'll arrive at the same answer no matter which one you choose. There's no wrong choice. Let's distribute the 5/2. And then we'll add 5 to both sides, but I'm going to call that 10 over 2 when I add it to the right-hand side, just so I have my common denominator in place. Final answer for that one, y equals 5 over 2x minus 15 over 2. Okay, and the grand finale here of our review, let's find some slope. M equals y2 minus y1 over x2 minus x1. That equals 3 over negative 4. And let's choose which point would be easier to work with. I'm going to choose that second one because it has a 0 in it, and those are very nice to work with when we're plugging values back in. Y minus y1 equals m times the quantity x minus x1. Since it's y minus 0 over here, all I have to do is distribute the negative 3/4. And that one is finished. There were some other things that we talked about that didn't show up on this review guide. The idea of parallel and perpendicular, how to use those to help us find slopes when we're writing the equation of a line. So you may want to look over that too as we prepare ourselves for this quiz. But for the most part, if we understand this review guide, this quiz, and the start of Algebra 2 in general are going to be very, very easy for us. So I hope these videos have been helpful, and I hope you feel prepared coming in. If anything still isn't making sense, please come see me in the morning, ask those questions before the quiz so that we take it as confidently as possible. Good luck, everybody.